participants, welcome to Multi-Cloud for You Data Sunday session on AWS Database End-to-End Project. The speaker of the day is Chandrali Sarkar. She is a data engineer at top Fortune 500. So, moving to who we are, what we are. We are Fifth IR, which stands for Fifth Industrial Revolution. We have over hundreds and thousands of strong community of technologists from all over the world. We deal with multi-cloud strategy, data science and AI, blockchain, and extreme engineering. We also help technologists to share their learning and get opportunities through our partners worldwide. So this is a short infographic of how we are growing. We have offered 1,000+ sessions through our platform, and we have 300+ speakers associated with our platform, and we have 27,000+ members registered in our platform. So these are the few MEPs and master mentors associated with our platform. We are academic partner of Alibaba Cloud, and these are the few courses which we have done in association with Alibaba Cloud. You can provide the link and you can get the certificate directly from Alibaba Cloud. How we can help you? We can help you to build your knowledge, digital presence, and help you in odd hours when you are looking for jobs through our community. Or you can access through the single link www.fifthir.com. Fifth IR stands for Fifth Industrial Revolution. As a part of our community, we are going to provide free participation certificate for all the participants. You can access the certificate by providing the secret code, and the secret code will be provided at the end of the session. This is a sample certificate which you can get as a part of our community, and you can share the certificate through WhatsApp, Facebook, and all the social media platform which is available over here. So moving to the speaker of the day, it is Chandrali Sarkar. She is a data engineer at top Fortune 500. She has been associated with different roles in the organization, such as IT analyst, system engineer, and developer. She's a certified cloud, AWS certified cloud practitioner, and you can see more about her in the given LinkedIn profile. So over to Chandrali.
Thank you so much, Gavaskar. So I'll get started. So I'll just let us start. So in the first, I'll start with what's a database and what's a data warehouse and what is a data lake. So we are acquainted with these terms in data, right? Data engineering or data analytics or data science as well. So database, does anyone know the difference between database and data warehouse? You can raise your hand as well if you want to answer. The difference between database and data warehouse. Yeah, Sudhanshu, please go ahead. What's the difference between a database and a data warehouse?
Yeah, so it's the one primary difference is like database is primarily for like OLTP, like all the transaction which we have like more kind of a normalized system, and data warehousing is catered more towards like OLAP kind of like where you have this denormalized data. We can afford redundancy, but we want to have most of the data at one place instead of like having multiple joins.
Okay, so can we see the data warehouse? One second. So can we say that data warehouse is kind of where we need to process a lot of historical data, right? So database is more about the transactional data, like daily data which is coming in, and analytical database, like Sudhanshu says OLAP. OLAP, what is OLAP? It is online analytical processing. Database is OLTP, which is online transactional processing. Okay, so I'll just share my screen once. Database, as I said, it's OLTP. It's most of transactional database, transactional data. Okay, so what's an example? Online banking transactions. Okay. Also, one more thing is about database. It's schema on write. So you must have heard about the term schema, right? So what is schema? Schema is basically the structure of a table. So what is a table? Table is basically where we store the data. So it has to be in a particular structure, right? So let's say we have 3 columns: age, name, and profession, something like that. Okay. So we need to have it in a structured way, right? Age should have only the age of people. Age cannot have a name like, let's say, Amit or something. So the structured form of data that is stored in a database, and it's a schema on write. So when we are writing the schema and when we are loading the data into that type of process is known as schema on write. So yeah, so main difference is OLTP versus OLAP. So OLAP and OLTP. So database versus data warehouse. So data warehouse, we can say that as I said, that historical data. So when we have to deal with, let's say, 10 years of history data, let's say business, so everything is about business, right? So if let's say business wants to analyze 10 years of data and they want to create reports out of it to understand the patterns and trends about how the company is working. Let's say I have a company and it's been 10 years to the company, and I want to understand the pattern of the customers, that what they are buying, how their choices have changed, how their preferences have changed. So I want to analyze the data. So how can I do that? I will do today versus 10 years back. So that historical data we can do with the data warehouse. So today's main agenda will be, first we'll talk about data lake on AWS. We are talking about AWS. So we'll talk about data lake on S3, which is S3, where we store the data. Then we'll talk about Athena. Then we'll talk about AWS Glue. And finally, we'll talk about Redshift, which is a data warehouse. Okay. So I just want to ask one question. Can you give me an example of a on-premise data warehouse? Not on cloud, on-premise data warehouse, a very famous one, which has always been throughout the ages. Starts with the name T. T for Tom. Anyone on the chat? Yes, Teradata, right. So have you used Teradata, Sudhanshu? No? Okay. You should try it once. It's really good. I have used it. So, all right. So, okay, we know about ETL, right? Extract, transform, and load. So what is the main agenda for it? So let's say we have a reservoir of data somewhere. Okay. So what we do, we extract from it. Okay. Then when we extract the data, that might be unclean data. Unclean data as in, let's say I was giving this example, right? Where in the age column, there are some names, right? Or data mismatch, data type mismatch. Let's say instead of integer, some characters have been put in. So these are junk data. These are unclean data. We need to transform this data. So there comes the T in ETL. Then finally it's L, which is load. So once we clean the data, we transform the data, like Sudhanshu also said, we normalize the data, we do everything possible to make the data presentable. I see, ultimately what is the goal? Ultimately the end point is that we have to present the data to the client, and client does not understand technical. So client will be wanting the simplified form so they can do the reporting and they can do their analysis. So that is the whole point of us being into data analytics or data engineering. We need to extract, transform, and load it. So do you have your AWS consoles ready? Or you can do it later as well watching the recording. But if you have your AWS consoles ready, do the hands-on with me. Okay, we'll be building end-to-end starting from S3 to Redshift hands-on. We'll be loading a data set and see that how these things work. Okay, give a thumbs up if you're on for it. Okay, so I'll be just sharing my screen. Okay, so let's start with S3. Okay, so first, how do we log in into AWS, right? I mean, I'll just quickly show it. It's very simple. You just create your account. You need to search AWS console, AWS management console, and when you go into that, you need to sign into the console. Okay, you will be asked for two things. One is root user and one is IAM user. I'll be talking about IAM as well. So I already have the account created. So when you sign up for it, when you will see new to AWS, you will need to create a new AWS account. And it's just simple 3 or 4 steps. AWS already guides you. So if you just see it, you have to sign in. So first you have to give your root user email address, AWS account name, whatever you want to verify it, and then it will come to the page where you will be able to create your account. Okay, so I'll just sign into my account. So I'll use the root user. Okay, so I am into this console. So this is the UI for AWS. Okay, so UI as a user interface, and we have the CLI as well in AWS, where you can use the Linux commands or the Unix commands to um, uh, dig into things or debug things. Okay, this is the user interface. So starting only, you will see that there is this drop down where I have selected the region. Okay, so when you start going into AWS, you will see that we have specific regions. So whatever, this is the closest to me, Asia Pacific Mumbai. So this one I have selected. So we have locations and regions where the AWS data centers are placed. Okay, so let's say this is all cloud, right? So cloud, what is cloud? I'll just quickly say the difference between on-premise and cloud. So what is on-premise? On-premise is, let's say I own a company and I have 5 employees, and everything is my cost. The maintenance of the servers, the maintenance of the computers, the cost bearing, the applications where I want to run my queries. Let's say I want to take Oracle. So I'll pay for the license. So everything is my cost and maintenance, even though I don't need it. But when we go to cloud, it's like renting an Uber. Let's say you want to go somewhere and you have your own car, as well as you can rent an Uber as well. So when you go with your own car, you have to pay for the petrol, right? And then the car maintenance is there. So everything is your own cost. That is on premise. But when you rent an Uber, you just pay for that particular trip. Nothing else is your headache. So you just pay, let's say 250 rupees, you reach your destination. Things are the same. So this is the basic difference. So on premise, you pay for everything, you pay for the maintenance. For cloud, let's say you only need a database service. So you only rent the database service from the cloud. It can be AWS, it can be Azure, whichever you are using. You just rent that and you use that service. So let's say in this case, we are using S3. Okay. So S3 is a data lake where if you are acquainted with Hadoop, you will see that there's a concept called HDFS. So S3 is the same as HDFS. We store the data over here. Okay. This is dynamic data. We store our files, right? Whatever files we are getting from the source, we store it over here. So how to uh, access this? So I already have a bucket created. So what we can do is we can create a bucket like this. Okay, so bucket name can be let's say multi-cloud bucket or something like that. You have to choose your region. So it's better that whatever region you are closer to, choose that, because there's a lot of things involved like bandwidth and downtime as well. If a particular region is down, so you can move to others. So choose your AWS region as per that. Now there is another option called copy settings from existing bucket. So if you already have an existing bucket created, let's say you're working in the project and you already have it created, you can choose the bucket from where you want to copy it. So let's say I want to uh, copy this bucket settings. So I'll choose it. Okay. And then there are certain other options as well. So block public access settings for this bucket. Do you want everyone to access your bucket? No, right? You don't want anyone to see what data you had, confidential data. So select that option. Then bucket versioning. What is bucket versioning? you will see AWS UI is very simple. Okay, it's very guiding. It guides you always. So it's a means to keep multiple variants of an object in the same bucket. Let's say you have one file, you store that, and then you make some changes, and then again you store that. So if you enable versioning, it will keep all the versions of the file, including all the changes. Okay, so this is how you can just see that what version you had in the beginning and what version you have in the end. You can use bucket versioning because of that. I'll disable it now. We don't need it. Okay, so everything is okay. If you want encryption, you can choose that as well. So let's say you want to encrypt your data, you want to encrypt the files present in your bucket, you can do encryption as well, so that no one else can understand what is exactly in the data, even if you give public access. And everything is done, then you create your bucket. I think it's okay, it's the same name, exists. Let's give it 1 2 3 4. Okay, so our bucket is created, right? Now what we will do is we'll go inside this, we'll create another folder. So S3 settings is like Unix, right? So you have a root folder, directories we could say. So you have a root directory, inside that you have subdirectory, inside that you have the file. So it's a path. Okay, so let's say folder name will give us data something. Okay, so create the folder. So data folder is created. Now we'll upload our file. So I have a file, I have a data set I downloaded. So I'll just add the file. I'll see that the type is a CSV. Okay, permissions, since I already gave the bucket, like I didn't want the bucket to have public access, so it will already assume that. For properties, you can give storage class. There are different, in S3 you have different storage classes. Okay, so we have standard ones where this is the availability zone, so all the services are not available in all the zones. Okay, so these are the availability zones. Availability zones are that this particular service, let's say, is available in this particular zone, so you can access that over there. So you have a lot of storage classes for that. We'll use the standard one, but they have different significance as well. If you see Glacier Deep Archive, what it does is it long-lived archive data access less than once a year. So let's say you have 10 or 20 years of history and you only want to retrieve it once a year. So you can use this Glacier Deep Archive storage class. Okay. And also the storage duration is also given. So as per that, you can choose it. So do not specify, we don't need an encryption key. This is just a demo. But if you want to specify an encryption key, you can select this, and you can give the encryption settings as well. So how is encryption done? That's a total different topic. It's through AWS S3 managed keys. It's dependent on what project you're working in. And if you want it, there's a different service. You can just create your key over there. So key as in you have a public key and a private key. So you can do your encryption with that. So I don't need an encryption key now. Okay. So these are optional. We don't need it. So upload it. Okay. So the file is uploaded. So you see the file is uploaded. It's a CSV file. So S3 is done. So now what to do? Now what we'll do is we'll use Athena. And searching services is also very easy. You just go in the search bar and you choose your service. So we'll go to Athena. So what is Athena used for? Why? Anyone who knows about Athena? What is Athena used for? Anyone? If not, then I'll continue. Okay. To query the data in S3, run SQL queries for analytics. Okay, query the S3 bucket. Okay, so can you tell me one thing? Let's say we need to create a pipeline. Okay, so when we create a pipeline and we have, let's say, TBs of data, okay, and it's very time, it runs every day. Okay, it runs every day. So let's say you have a file in S3 and there's a job which is running every day, which extracts the data from it. Do you think Athena is suitable in that case? Or let's say it's a streaming data. Let's say it runs every hour. Every hour the job is scheduled to extract the data from S3. So in that case, is Athena suitable? Yes or no? Whatever comes to your mind. Is Athena suitable in that situation? Yes, no? We have a very quiet audience today. Athena is tool suitable only for static data. Okay. Athena should run every hour. Okay. So do you know about the cost of it? That, right. So what is the cost for querying per byte of data? What is the cost thing in Athena? Anyone knows that? Okay, let me share my screen. So let's do Athena. Okay, Athena in the most suitable case is the most suitable in situations where you have an ad hoc request. Okay, let's say we have to schedule a job every day. Okay, and we are doing incremental load. We are not doing full refresh. We are doing incremental load. Let's say we are doing upsert. Okay, insert and update both. In that case, we'll need a powerful data warehouse to store the data. Let's say if the job is running every single hour. Athena is for ad hoc requests. Let's say a client has given a sample file to me just to see that how the pipeline can be built, just to understand the data. Okay, we have the data in S3, we just want to understand the data. That is the best use case for using Athena. Okay. Okay, so is my screen visible? I think. Okay, so now let's do one thing. So I already have a database. What we'll do is we'll create a table based on the data we just uploaded in S3. Okay, and then we'll query it and see what happens. So what I'll do is I'll show you both the ways how to create a table. Let's first create using an S3 bucket. So let's say table name is table underscore demo 1. Okay, description optional, I don't need it. Choose an existing database. I already have a database. If I want to, let's say I want to create a database, so I'll create a database. Let's say what name to give? Let's say multi-cloud underscore new. Okay, so I create a database. Now where is the location of the input data set? So I'll browse my S3. This is the path I did, right? So I'll just select this folder level. Okay, now table type Apache Hive. Hive is for data warehousing. File format is Parquet. You can select different file formats as well, whatever feels suitable to you. Okay, Serde properties, it's optional. I'll talk about Serde properties later. For external tables, when we create external tables, Serde properties are needed. I'll talk about that. So let's say column details. Okay, so the data I have, I think I need to share the whole screen. 1 second. Okay. Yeah. So the data I have is this. Okay. User ID, subscription, monthly revenue, join date, last payment date, country, age, gender, device, plan duration. Let's add the first column, user ID. So user underscore ID. Select a column type. Let's give it begin. Description not needed. Now, if I want to add another column, let's say I want to add another column. So let me give subscription type like this. Okay, give me a column Sorry, I didn't get it. Okay, column type, so subscription type is character. Yes, so we'll give it as a okay. So this wants the length, let's give it 50. So it's basically instead of, so we have the, instead of creating, we can use the create statement also. Instead of using the create statement, what we can do is we can either use this create table statement, or what you can do is you can create it from here as well. If it says bulk add columns, so what you can do is you just give the data types like this. So next column is let's say monthly revenue. So you can just write it like this, like monthly revenue, and then the data type. Okay, let's say like this. So you can use the bulk columns like this also. Okay, now I'll not go into much details, and then once you do it, you just need to, you will see the table query is here, and then you create the table. So your table will be created like this. Okay, this is one way. Then what is the next way? We can use a glue crawler. Okay, so what is a glue crawler? There's another service called AWS Glue. So in AWS Glue, there are multiple advantages. So number one, it's an ETL tool. You can create your ETL job and automate it as well. You can use Lambda. You can use your Spark job in the script. You can use your Python job in the script as well. There are a lot of other languages which Glue supports. So it's an ETL tool. Okay, you just write your script. You provide your data source, let's say S3, and then you provide your destination as well. If you want to do Redshift, you do Redshift. If you want to do any other destination, you do that. So it's an ETL tool. Another advantage of Glue is that it has a crawler. So what this crawler does, the crawler basically what it does is, second, yeah. So let's say this is my S3. The data is over here. So what AWS Glue crawler will do, it will crawl the data. Crawl the data as in it will scan the data, scan that particular data set, and it will create your table based on that scanned data. Okay, so let's say in S3, I have this file. So what Glue crawler will do is, it's like an insect. It will crawl this. It will see, okay, first I have user ID, then I have subscription type, then I have this, then I have this. So it will crawl the data, and it will create your crawler. It will, and what will the, when you run the crawler, what it will do, it will create your table based on exactly this data types, this column names, and this values as well. Let's see on demo. Okay, so let's create a crawler. So let me give like, since this is Netflix database, so Netflix underscore crawler. Description not needed. Still you can give Netflix crawler. Tags optional. Next. Okay. Is your data already mapped to Glue tables? We don't have it. So not yet. And now add a data source to it. So data source is S3. You have other things as well, JDBC, DynamoDB, DocumentDB. So MongoDB is a NoSQL database, then Delta Lake, Iceberg. So all this type of data sources you have. In this case, we'll be using S3. So JSON file or CSV file or Parquet file, whatever files you have in S3, we can create a glue crawler with that. Okay. Now, location of S3 data is in this account. You can also crawl data from different accounts. Different accounts as in, let's say Sudhanshu has an account. If I choose this option, let's say I choose this option, I will have to give the path for it. Okay. So in this account, let's browse it. This one. I'll go inside. So yes, this one. I'll crawl the data. So since I chose this on a folder level, whatever files are present in that, it will crawl all the files. So one file is now there, but if you have multiple files as well, it will crawl all the files. Okay, so let's say you are getting something on a daily basis, so you can crawl all the files as well. Okay, so we need a slash like this. Okay, crawl all subfolders, crawl new subfolders only, crawl based on events. The three options are there. I'll choose crawl all subfolders. Whatever happens if I choose crawl new subfolders only? So what it does is, since the last crawl, let's say I have an crawler now and I run it. So after that, if I add another file or if I add another folder, since that update, it will be crawled. Okay. And if I do all subfolders, then with every subsequent crawl, let's say I run the crawler every time, it will crawl all the subfolders. Okay, so this is like an incremental crawling. Okay, you can do that, this one as well. If you have something like you are getting data every day. So since the last crawl, you don't need that. That's already there. The new ones, you need to scan it. Okay, so now this is not needed. Add a S3 data source. So I have added it. Now custom classifiers optional. Next. Okay, this is a very important part. Choose an IAM role. So what is an IAM role? IAM is identity access and management. So let's say I run a company and I have developers, I have testers, I have DevOps team, I have management team, I have different people in different roles. So obviously that access or the access I give to the developers, I won't be given the same access to the testers also, right? The testers won't be needing those access. So what we do is we assign different roles. So what happens in those roles, I'll show you IAM as well. So you just search IAM like this and you go there. Okay, so you see that this is a dashboard. So you have user groups, users. What are user groups? User groups are like what I said, like developers, testers, managers, DevOps. These are different groups. Okay, users are the employees. So if let's say I have 5 developers, those 5 developers will go to the developers user group. Testers, 10 testers will go to the testers user group, like that. Now, what are the roles? So when I see roles, let's say I want to create a role. I create a role. The trusted entity type is AWS service. So what this option will do, allows AWS services like EC2, Lambda or others to perform actions in this account. So whatever services I have, that it will allow to access in this account with this particular role I'm creating. Okay, there are other things also. AWS account web identity. AWS account allows entries on other AWS accounts belonging to you or a third party to perform actions in this account. So it's account to account relatability. Okay, so use case so common use cases. So let's say we choose Glue. Okay, so allows Glue to call AWS services on your behalf. I'll choose this. Next. Okay, so what do I need? I need, since I'm using Glue, I need to crawl the S3 as well, right? So I will choose S3. I will choose S3 full access. Okay, for precaution, you don't choose full access. Let's see, if you only want to crawl it, you do read-only access. But just for demo, I'm showing Amazon S3 full access. Okay, so in this role, I'll give Glue as well to access the Glue service. So Glue service role, this policy will be used for Glue crawler and job execution. So I'll choose this one. Second. Yeah, so S3 and this one, this two I will choose. And then next, role name, let's give AWS service for Glue crawler. Description is already given. So this is the statement. Okay, this is how a role statement looks like. So service, which is over, so effect is allow. What is the service? glue.amazonaws.com, and action is that assume role. So this already is created. This is JSON format and this is already created. Okay, so I have this S3 full access glue service role. Okay, now let's create this role. Okay, done. So, okay, now what we'll do is, where were we? Where's the crawler? Yeah. Okay, so we'll choose the IAM role. Okay, and update chosen IAM role. Okay, 1 second. Let me do it again. Netflix underscore crawler. Next, add a data source, browse S3, choose. Remember to put this slash, otherwise it's an error. Okay. So I have two of them. This one was previously created. I have this one also. Let me choose this one, the previously created one. Next, choose a database. So this database multi-cloud. Table name prefix. If you want to add a prefix to your table name, you can do that. Let's say you want to do it in prod, so you do prod, or if you want to do it in pre-prod, you do pre-prod, like that. Okay, so it's optional as well. So maximum table threshold. So at a time, the maximum number of tables the crawler is allowed to generate, that threshold. Let's say I give 5. Okay, so if I do the 6th table, it will not do it, because the threshold will be crossed. And frequency is on demand. There are other things also, hourly. Let's say if you want a crawler to crawl every day, so you do daily. If you want to do it hourly, like that. Okay, custom is also there. Let's say every 5 hours, if you want to do, you can do that. So this one I'll do on demand. Next, review and create crawler. Okay, so crawler is created. Now I'll go to the crawlers. Okay, so let me run this. So when it will be done, it will show me succeeded, and the table change, it will show that 1 created. Okay, so the table name that I gave, it should be created with that name. And how will we know that? We'll go to our Athena. We'll see our tables over here. The test table is created over here. Okay, so any questions till now? Let this crawler run. After this, we'll do Redshift. Any questions till now? Yes, no. I assume no, then? Okay. I'll share again. Okay, so it's showing me the table change 1 is created. Okay, let this be ready and succeeded. Okay, so I gave as data, right? So this table is created, you see over here. Now if you want to query it, let's say select user ID, only one column I want to give, from data limit 5. Let's run this and see. One second. One second. See this. Okay, so Okay. See, in this, when you go to tables in this, you will see that user ID, subscription type, monthly revenue, join date, last payment date, all these columns, and that along with the data types. So I didn't specify any data types also, right? Whatever was in S3, it just crawled and it suggested and it created the data type. Okay. So I think this is the thing. Shouldn't be. Okay, I think, yeah. So in this data set only, we need to give the underscore. Okay. So based on that, so whenever you have the data set also, you can just do that. Okay. So now let's, 1 second, it's the crawler. So what I'll do is, okay, one more thing is CloudWatch. So whatever you run, if it's a crawler or it's an ETL job in AWS Glue, you can see all your logs in CloudWatch Manager. So let's say if you run a crawler and it fails, it's in a state of error or failed or something, and it's errored out, you can see the log over there that what went wrong. So everything is present in the log in the CloudWatch. So this is another service where you can see your logs and the log groups. Okay. So this is about Athena and AWS Glue crawler. So now since we have already created this table in Athena, I'll go to Redshift. Okay. So 1 second. I already have a cluster up and running, but I'll show you how to create a cluster. So in Redshift, you can either do it cluster wise or you can do with Redshift Spectrum. So as in Redshift Spectrum, what happens is, second, okay, let's first see the cluster thing. So I already have a cluster. So Redshift Spectrum, sorry, Redshift cluster. So let me show how to create a cluster. It's very simple, easy steps. So Redshift cluster 2, the name is, choose the size of the cluster. So if I choose it, so you will see the node type. So what are the nodes? Does anyone know what are the nodes in Redshift? There are compute nodes and what else is there? Anyone? Okay. So first tell me one thing, that why Redshift, right? So what is there should be some disadvantages of using the traditional warehouses. Like I was okay. So we were creating a cluster. So what are nodes? So if you know about the Hadoop architecture, right? So what happens? There is a master node and there are some slave nodes, right? So the master node is like the worker node. And in here also, the architecture is basically like there's a leader node. I'll show it once in Paint. So there is a leader node like this who is sitting on the top, and then we have the compute nodes over here. So these are the compute nodes and these are the leader nodes. So this is the Redshift architecture. Now this is the master and these are the slaves which is following the master. Okay. So what this is, and this whole thing comprises of a Redshift cluster. Okay. So what happens when there is only one node cluster? Let's say in the cluster we have only one node. So that one node only behaves as the leader and the compute, both. So if you have more than one node cluster, multi-node, so the leader node will be separate. If you have a multi-node cluster, there will be a separate leader and there will be compute node separately. So in this, if you see, number of nodes is 2. So we'll have a leader node separately, we'll have a compute node separately. And the node type is this. So based on your requirements, you can do that. Let's see if you want to do RA3 XL plus. So this is giving the managed storage up to 4 TB for single node clusters like that. So it normally the cluster size and everything is decided by the project itself. But if you're doing a demo and if you're doing a project on your own to show in your resume, choose RA3 4x large. Okay, and number of nodes 2 only, because when you increase the number of nodes, the other compute nodes will eat up the resources. So better to do 2 nodes so that you understand the leader and cluster difference. Okay, so there is another option, sample data. So if you want to function Redshift with sample data, you can load the sample data. If you uncheck this box, you will see that there is a sample data which uses a sample database, but we have the data, right? We loaded the data into the data catalog using the crawler and in Athena as well. So what is the data catalog? Whenever you are loading some table, whenever creating some table and loading the data, that goes into the data catalog, AWS data catalog. So you can either query that from Athena, you can query that from RDS, you can query that from Redshift once you have the table. Okay, so admin username, you need some username and password. So this username is given by Redshift. You can change that as well, whatever you want to. I'll keep it as AWS user. Now password, either you can auto generate the password, Redshift can generate for you, or if you can give the password as well. Note that special character likes @ backslash, comma, quotes, these will not be used. So keep it very simple. Okay, now associated IAM roles. Okay, so I already have an IAM role which I can select. So you can also, if you want to create an IAM role for Redshift specifically, you can just create an IAM role over here. And or you can directly go to the console over here where you have the IAM and you can create it for Redshift like we did it for Glue. So I'll just select this, create cluster. And also remember to close your cluster. Okay, so let this cluster be created. So it's the same thing as cluster 1. So what I'll do is, so we have the data in S3, right? So I'll create a table from Redshift. Okay, let's say Netflix _ DB3. So I have already have this table. What I'll do is I'll do another one, Netflix _ DB4, and let me create this. Okay, first you have to connect to a database. Since I was away from a long time, so it did not get connected. Okay, so use a recent connection, Redshift cluster 1 available, connect to your database with the cluster. So once it's connected, you will see that the schema, you can create your own schema as well. You can create like create schema data, something like that. Select it, run it. Okay, so you will see that in the schema, these are the your data schema is also created. Now let us create a table. What we're trying to do is we'll use the data in S3. Okay, let's say I am just creating this table. Okay, this is an empty table. We don't have any data into it. So instead of inserting it separately, we can load the data from what is present in S3 and it will come to this table only. So for that, you can use the copy command in S3. There are two commands. One, if you want to copy data from S3, one is copy command to copy data from S3 to your Redshift. Another one is the unload command. What unload does is Redshift table to S3, vice versa. Okay, so let us do the copy command first. So what is the command like? So copy table name. So this will be 4. Copy table name from, this will be the S3 path where your data is present. So for our case, it will be this one, right? So you select that folder, you do copy S3 URI, not URL. Copy S3 URI and you copy it over, paste it over here. Okay, so the IAM role, what is the IAM role you need to give? So the one which you attached with your cluster, right? So for this, let's say I go to cluster 1 and you go to maintenance. Sorry. Yeah, so you go to this, you will see when you select this IAM role, there is an ARN being generated. Okay, this ARN you need to copy and you need to paste it over here. And you need to specify the delimiter as well. So whatever delimiter was in the file, in this case it is a comma. In the CSV, if it's a pipe, you can give a pipe. Whatever the delimiter is, you can just give that. And you run it. Okay, there's an exception. Requested role not okay, this role is not associated with the cluster. 1 second. Okay, so after I run this, the data will come. I'll just run it. One more thing I want to say, that there is another table called STL underscore. Okay, so there's another table which is called STL load errors. So if you just query this table, so if you are having any problem, if you're facing any issues with loading or while querying from the tables, you will see that there is another table. So whatever query you, I mean, every time you run this query, you will see that what is the error. So I was running this another table, right? Netflix DB3, which I was doing the copy command for. So you will see that this is all the details, the logs is coming over here. So the file name, line number, where it is the problem. So initially I was getting problem for this column name, user ID, type is integer 8. So whatever error is there, okay, error reason, delimiter not found, invalid digit, invalid date, all of this will be captured in this one. So when you are in your project also, always keep a look of this this table, STL underscore load errors. Okay, now so let's query this from the copy command. Okay, now you see that I did limit 5, right? So so whatever, so the first 5 columns which we had in this data set, it has come over in using the cluster. Okay, now the second, so this is the copy command we were talking about, right? Now the second thing is the unload command I was talking about. So it's the same thing. It's the same thing. Just what you need to do is that if you want from Redshift table to S3, then you use unload. So copy is basically S3 to Redshift and unload is Redshift to S3. So the best use case I had for unload command is that I was using it in a Python script. Okay, so we didn't have a simple select star. We had some complex stored procedures or something. So we just placed it in, a parameter in this unload, and we unloaded the data from S3 to the, sorry, from the table to the S3 bucket. So I ran this command just before this session. So select star from Netflix underscore DB3. So 2, this S3 will be the destination. So let's go to our S3 once. S3, yeah. So let's go to our S3. So what I'll do is I'll create a destination folder here. Okay, 1 second. I'll create a destination folder. So create the folder. So I'll unload the data. So let's do limit 5 or something like that. I'll unload the data to this one, destination. And IAM role will be the same, which is associated to a cluster. Okay, and I'm giving the delimiter as pipe, and it will gzip also. You can use compressed or uncompressed as per your requirement, but it's better when you are loading somewhere, just use your compressed version. Okay, I think it's okay. Limit clause is not supported. Great. So let us do whatever we have. Okay, so it's completed. Now let's go to our cloud bucket. Let's go to destination. You will see that it has compressed into different parts, and the data has come to your S3. So this is how unload works. So this was about clusters. Okay. So one more thing, whenever you are done with your cluster, please delete it. Otherwise you will be charged unnecessarily. Whenever you are done with your cluster. Okay. So cluster 2, I think I deleted. Let's delete both of them. 1 second. Okay, first let's delete this one. Okay, I'll delete later. So yeah, now another thing in Redshift is that you can use Redshift Spectrum as well. So it's very simple. Redshift Spectrum, it's just basically like using an external table. Okay, so what you can do is you just need to write create external table, let's say XYZ, and then you give column name, data type, whatever it is, and then you give your partition by whatever, let's say file date partition or something like that, and then you give your sorter properties. Okay, sorter properties you give, then you give your table properties. So basically the syntax of your external table. Okay, and then you give your location wherever your S3 path is, so the S3 path. So it's a dynamic thing. Whatever is present in the S3 path, if just when you create this external table and you query the external table after it, let's say from table, so you will get whatever is in your S3 path. So this is dynamic, this is not physical. So what we were doing with copy command is physical. You were just loading the data in that table. But when you are using Redshift Spectrum, what is happening is if the file is removed from S3 path, the data will also be removed from the external table as well. So this is the difference between Redshift Spectrum and Redshift Cluster. Clustered is costlier to maintain. Redshift Spectrum is again, you can do the same thing in Athena as well, right? So but Redshift is, since it's a warehouse, the power is much more. That is why mostly in projects, what my project does is we use Redshift Spectrum. we bring it to landing zone layer, and then we move it physically with some sort procedures. We migrate the data with some sort procedures. We don't directly use the copy command and everything. Okay. So yeah, this is mainly about the end-to-end database. So once your data is in Redshift, like it was here. So once your data is in Redshift, what you can either you can use Tableau or you can use Power BI to connect to this Redshift data warehouse source, and you can use the create the reports based on it. Okay. So now we can go to the Q&A. If anyone has any question, you can write in the chat.
So participants, you can unmute yourself and you can ask your questions, or you can type the question in the chat. Yeah, one question. Can you explain your project little end-to-end overview?
Can you explain? Sorry, I didn't get this question. Little
Yeah,
end-to-end overview. Yeah, I mean,
yeah.
this is what we are doing, right? First, we stored it in a data lake, which is S3 in this case, and then we are creating the Redshift pipeline, right? So we are migrating it to the data warehouse. So in that case, you can use the AWS Glue also. With the crawler part, you can schedule a crawler daily to bring it to, to your table, and you can use Redshift also. Can you please explain a real-time project of data pipeline? Yeah, sure. So let's say we have the data in a mainframe server, okay? And we are using MFT, if you know MFT, it's an SFTP server. So we are using an SFTP server to bring that data to S3, to the cloud. So once the data is in S3, what we are doing is we are creating a Lambda job. So when we are creating creating the Lambda job, we are doing the transformation over there only, or you can use a EMR job also. Okay, so you can use the Spark over there. So you can use the EMR job, and once you are using the EMR job, you write the transformations in Spark. You extract the data from that S3 folder. You write the transformations. You do the transformations, and in the destination, you are giving, let's say, another S3 path. Okay. And then from that S3 path, you can use Redshift Spectrum to create your table. And inside Redshift Spectrum only, after that you migrate to another physical table. So based on that physical table, you use Tableau or Power BI to create your reports. So this is how so you're involving the EMR, you're involving your EC2, you're involving data lake S3, you're using data warehouse, and then you're using Tableau or Power BI. So you can use QuickSight, Amazon AWS QuickSight as well to create your reports.
So participants, any more questions? So I think we can move to the certification task. Yeah, let me share the screen. So participants, the speaker code to download the certificate is M7H0ER. So already I have shared the link to download the certificate as well as the speaker code in the chat. You can utilize that. So again, I will be providing that to you. Yeah, that is a wonderful session on AWS Athena and AWS Glue Crawler. And that is an end-to-end project, a database project using AWS. On behalf of Buttercloud for You, we'd like to thank Chandrali for providing a wonderful session on the topic AWS end-to-end database project. Again, I like to thank all the participants who are attending the session, and have a good day. Thank you. Centrally, thank you.
Thank you so
Yes,
much.
wonderful.